In today's video, we'll be looking at a question from Newton's laws of motion, which reads, when a force of 450 Newton pushes on a 20 kg box as shown, the acceleration of the box up the incline is 0.70 meter per second squared. Find the coefficient of sliding friction between the box and the incline. Alright, so let's find the coefficient of sliding friction. Well, let's take note of the forces which are acting on the box. So this is our incline. Then we have our box here. So we know that the weight will be acting downward, right? And the same weight will have components. Same weight will have components, right? So this is the normal force. So this is the W cos theta, or mg cos theta. This is W sin theta, right? And the angle here is 45, which is the same one as this angle which is here. Okay, right, amazing. So now, what force will cause this box to move upward? Okay, we've got this force, right, which is the 450 Newton force. So I've got a force which is acting in this direction. So the force is acting in this direction, right? Yes. Meaning that this angle and this angle, these two angles are the same. Okay? What else do we know? We know that the force which will cause this box to move along this incline will not be the entire force, no, but rather will be the component of this force which will be parallel to this incline. Okay, the component of the force which will be parallel to this incline. If this force, since this force was acting in this direction, if this force was acting in this direction parallel, then we would have taken the entire force as it is. But in this case, we need to find the component of this force, okay, which is parallel to this incline. How do we find that? In this case, we are saying the one which is parallel. Amazing. So we can take it from this side, or even from this same line. Okay. So this is the force that we want. This is the force that we want. So since this is the angle, this component will be the F sin theta. What about for this one? This one will be the F cos theta. So this component of the force is the one that will make this box to move upward. Well, what about for this component? This component, since it is acting towards the incline, it will increase the normal force. If this force was acting upward, then it was going to reduce the normal force. All right. So we can come up with the formula from there. So therefore, we'll say what force will cause this thing to move upward will be the F cos theta. So the F cos theta, and what forces will be acting against the F cos theta? The first one will be the W sin theta. Okay, so the W sin theta will be acting downward. Okay, that is the result of what? Of gravity, right? Because when something is laid to slide, what force will be causing the the same thing to move downward, it will be this force. So as this thing is moving upward, this force will be acting in the opposite direction. We'll be trying to pull the box downward, right? So in this case, F cos theta minus W sin theta. Any other force? Friction force, right? Yes, because friction always acts against the what? Against the motion, or the direction of motion. In this case, also I've got friction force. This entire thing will give us what we call the net force, and it is this same net force which will produce a certain acceleration. In this case, this same net force produced the acceleration of 0.70. Right, this is amazing. But we know that W is the same as mg, which is the weight, right? Sin theta. Friction force, how do we find friction force? Friction force is equal to coefficient of friction multiplied by the normal force, right? So coefficient of friction multiplied by the normal force. The net force is given by MA. All right. Okay. So from there, we can actually make this the subject of the formula. So we can just say coefficient of friction by normal is equal to, so yeah, you know how it's done. Okay, so we are making this the subject of the formula, right? So it will be this, like going to the other side. I know there are better ways to use, but for now we can stick to the same one. So F cos theta minus mg sin theta minus ma. Okay, so it will be over normal. Therefore, the coefficient of friction is going to be equal to F cos theta minus mg sin theta minus ma over normal force. Okay, over normal force. Amazing. Okay, so let's write this formula here. Coefficient of friction is equal to F cos theta minus mg sin theta minus ma over normal force. Right, so this we have them, yeah. But what about for the normal force? How do we find the normal force? Well, from this, the normal force usually is given by the W cos theta. But in this case, since we also have this force, okay, from this force, all right, this same force. So from this same force, there is a component of it which is acting downward. In this case, this will increase the normal force. As a result, the normal force will be equal to the W cos theta plus the F sin theta. If this force was acting in this direction, then we are going to say normal force is equal to W cos theta minus F sin theta. Right? So we can replace our normal force. Normal force is equal to that. Yeah. Okay, cool. You can just do this. F cos theta minus mg sin theta minus ma over, what is our normal? Our normal is this one, W cos theta, but we know W is mg, so we say mg cos theta plus f sin theta. Right. So what is our F? We can now replace, right? The F, which is the force acting, is this one. So the F, which is 450, so in this case it would be like 450 multiplied by cos theta, which is 45 cos 45 minus, what is the mass? The mass is this one, 20. Gravity, we use 9.8, but it depends with your school. Stick to your school. By sin theta, sin 30 minus the mass, again 20, by what's the acceleration? The acceleration is 0.7 over mass is 20, gravity 9.8, okay, by cos 45 plus f sin theta, which is, that is f is 450 Newton times sin 30. All right, why am I using sin 30? Okay, so it's sin 45 everywhere. Yeah, sin 45. All right, yeah, sin 45 everywhere. So in this case we can just punch everything on top. So punching everything, 450 by cos 45 minus 20 by 9.8 by sin 45 minus 20 by 0.70. Right. Okay. This gives me 165 point. I don't know what you are getting from your end, but from my end I'm getting something like this. Okay, so divided by, so in this case we say 20 by 9.8 by cos 45 plus 450 by sin 45, which is giving me 456.7909.806. So dividing gives the following answer. So dividing gives this. Yeah. So you can just say therefore. Yeah, that is if you want. Therefore, the coefficient of sliding friction is equal to 0.36363. Doesn't have units because it's the coefficient. Thank you so much for watching. Thank you. I really appreciate